Hello and welcome to Ganesh Institute channel. So in today's video, we are going to discuss some derivation regarding curl and gradient and divergence as well. So what we can do, let me recapitulate how you can find out the gradient by taking partial differentiation along with x, y and z direction, right? How you can find out the divergence by taking dot product of gradient and that function. And how you can find out curl? Curl is the cross product, right? So let's begin. Here you are given with two derivation that find out divergence of gradient of function and find out curl of gradient of function. So what we can do, first of all we know gradient of function will be del x partial differentiation with respect to x, right? Partial differentiation with respect to y and partial differentiation with respect to z. Now divergence of gradient f will be this dot product, right? That means this is the symbol because it has f, so you have to write it as f. Thereafter, this is your gradient and your del f is this. Let me write it here. Dot product, right? Now if you do dot product, you know I dot I is 1, correct? This is f. So I dot I is 1. It has become now double differentiation of f. Similarly, j dot j is 1. Double differentiation of f with respect to y, right? Similarly, double differentiation of z. Double differentiation of f with respect to z. So what you can write it like, this is your del square f, which is called Laplacian operator. Okay. And if you want to find out Laplace equation from this, so Laplace equation will become, just put Laplacian operator as 0. That means this equation equals to 0, then it will become your Laplace equation. Okay. So this was your divergence of gradient of function. Now let's move on to curl. So curl is nothing. You have already found out gradient of f, right? Now for curl, you need to take cross product, correct? So now this is your del, this is your cross. How you can find the cross of this? Let's find out. Let me grab a duster. So the curl will be I, J, K. I discussed this in our last video, right? You can check it out. So I, J, K, and second part is partial differentiation with respect to I, with respect to x, y and z respectively. And here, if the function is in the form of ai, bj, zk, then you have to write down abc. What is ABC here? You can see your function is in the form of this, correct? Del of del f, and f is actually your find out because you want to find out curl of gradient f, and gradient f has already got partial differentiation factors, right? So for curl, your factor is this. So I part is of f with respect to y, of f with respect to z, right? Now let's sort it out. So hide I, what is left? So you can see it will become d of dy of df and dz, right? So what it will be? Del square f, correct? Minus, this is the formula for determinant, right? I, you have to cross multiply. You did this. Now this will be double partial differentiation of f with respect to y and z, right? Similarly, j, hide this, double differentiation of f with respect to x and z, right? Minus is in formula. You are hiding j, so second part is double differentiation of f with respect to x and z. And k factor, now hide the row and column in which k exists. Double differentiation of f with respect to x and y minus double differentiation of f with respect to x and y. You can see all these terms are similar, so it will result into 0. So curl of gradient of f, that means del cross del f, is always 0, and divergence of gradient f is del dot f, and it is del square f. Alright, I hope you understand these derivations, and if so, then don't forget to like, share and subscribe my channel. Till my next video, don't forget to take care of yourself. Bye bye.